Welcome to qnawire.
We have following situation. A ball here makes a contact, contact with the two balls here, and they are making an angle with horizontal here, a theta. So a theta here and making an angle theta here. The distance, the radius of the ball is r here. So the diagram here shows the incident ball, which is a leftmost ball, makes a contact with the two other balls here. This is x-axis. So this left ball exerts an impulse of the same magnitude on each ball along the line that joins the centers of the incident and target ball. The target balls leave the collision along those lines, while the incident ball leaves the collision along the x-axis. The three dashed, so these dashed, this is a dashed, and this is a dashed line. The three dashed lines that joins the center of the balls are in contact form an equilateral triangle here. So both of the angles marked here are theta, are 30 degrees. Let v0 be the velocity of the incident ball before the collision, and capital V be the velocity after the collision. The two target balls leave the collision with the same speed. Let V represent their speed. Each ball has got a mass m. Since the x component of the total momentum of three-ball system is conserved, we can write mv0 is equal to mv plus 2mv cos theta. Then, since the total kinetic energy is conserved, we can write simply 1 over 2 mv0 square plus 1 over 2 is equal to here mv square, v capital square, plus 2 times of 1 over 2 mv square. We know the direction in which the target balls leave the collision, so we first eliminate capital V and solve for a small v here. The momentum equation gives us v is equal to v0 minus 2v cos theta. So v square is equal to v0 square minus 4, taking square on both sides, v0 v cos theta plus 4v square cos square theta. Then and the energy equation becomes v0 square is equal to v0 square minus 4v, so this is small v0 here, it's not capital. v0 v cos theta plus 4v square cos square theta plus 2v square. Therefore we can write v to be 2, this is small v, v0 cos theta divided by 1 plus 2 cos square theta. We'll substitute the values and solve for v. 2 times 10 cos 30 divided by 1 plus 2 cos square 30. This gives us 6.93 meter per second. This is the final speed of the ball 2 as labeled in a given figure, which is 6.93 meter per second. Part B, the direction of a ball 2 is at 30 degrees counterclockwise from positive x-axis. Part C, the final speed of the ball 3 is again 6.9 meter per second. The direction of the ball 3 is at D is at minus 30 degrees counterclockwise from positive positive x-axis. Part E, from the momentum equation, we find the final velocity of the ball 1, which is of capital V is equal to V naught minus 2 small v cos theta. Substituting values, 10 minus 2 times of 6.93 times cos 30. This gives us minus 2 meter per second. Part F, the minus sign indicates that it bounces back in negative x-axis direction, and the angle is a minus 180 degrees.